Hello. A quick demonstration of how to go through and do this assignment. It's a little bit different layout than normal, so I thought maybe this would be helpful. Um, we're going to collect data off of devices at home, toaster, microwave, toaster oven, coffee maker, any of those sorts of things that you have in the house. If you're not able to find the data for these and you still need the power rating for things, there's a link here that will allow you to go through and just find some stuff. Otherwise, instead of clicking on this link, you can just go down here, click on appliance data, and I just included links to devices available at Target. Um, but for me, I know my toaster. I went and looked on the bottom of my toaster, and it said that it had 900 watts of power, or it's rated to use 900 watts of power. So I know my toaster, 900 watts. The microwave and the toaster oven and the coffee maker, I can look those up as well. But for now, just to make sure we see one example worked all the way through, I'm just going to go with the toaster. Oops, I scrolled down and that buggered things up. Go back here, 900. Enter. All right. So in your version, you will only be able to enter data in these columns like that there, and in these spots here. Um, I made it so that you wouldn't accidentally remove something that you needed later. So I've got the power rating or the wattage for the toaster there. Now down here, I'm going to try to calculate current that goes through the toaster. We know the toaster is rated at 900 watts. And when we plug things into an outlet, they generally use 120 volts. So here, I'm going to try to calculate the current through the toaster that plugs into 120 volt outlet and uses 900 watts of power. And here it says, hey, use this power equation to calculate the current through your device. So pencil and paper will be helpful for you to do this. You can't type in this cell, I can. So I'm just going to use this as a little spot for notes here. So the power equation is power equals current times voltage. Now, if I want to rearrange that and I want to get current on its own, because that's what we're solving for down here, then I would divide. Right now I'm multiplying current times voltage to get rid of voltage, so I have current on its own. To get rid of voltage, so I have current on its own, I would do, to get rid of voltage, I would, well, divide this side by voltage, or by electric potential. And if I divide that side by electric potential, I need to divide this side by electric potential. And in so doing, I end up with um, power divided by electric potential equals current. And the math department always likes us to have that one thing off on its own, so we'll accept that. So these first rows are really just me getting current on its own. Excuse me. And now that I have current on its own, I'm just going to plug in these values, 900 watts or 900 joules per second, 900 watts divided by 120 volts. And if I punch that into my calculator, 900 divided by 120 volts, I get current equals 7.5, and it turns out that that's amps. But when I put my answer in here, it needs to be with just numbers, not no letters. And now if this is right, we should see that cell changes to being outlined in purple. And that should happen for the rest of these as well if we get these correct. So right now, we know that that one's correct. Now, notice that if I put in 7.5 amps, it doesn't know how to double check that. It can't calculate if I have the letters in there. So I need to leave that as 7.5. And if up here, if I mistakenly put in 900 watts, then it doesn't show this as being correct because again, it can't calculate if there's letters in that field. So we need to make sure that when we're entering data into a spreadsheet, we only include numbers, no letters. And now we'll go down to this next part. This next part says to use Ohm's law to calculate resistance. Um, I'm going to use this same cell up here as just like a workspace. Um, Ohm's law, as we've discussed it, as we've used current equals the potential difference divided by the resistance. Well, in this case, we know the current and we know the potential difference or voltage. We're trying to find the resistance. So the first thing I need to do is to get resistance out of the denominator. So to do that, I'm going to multiply this side by R. And if I multiply one side by R, I need to multiply both sides by R. If I multiply both sides by R, I get current times resistance equals the potential difference. So we're a step closer to having resistance by itself. Now, if I have current times resistance equals voltage or potential difference, now I need to get rid of current. So I have resistance by itself. So to get rid of current, right now I'm multiplying those two. So to get rid of current, I need to divide by current. If I divide by current on one side, I need to divide by current on both sides. So now I get resistance equals the potential difference divided by current. And if I plug these numbers in from what we've already calculated, I get resistance equals, we plug it into 120 volt outlet, and we divide by the current of 7.5 amps. And if we punch that into your calculator, I get an answer of 16 amps. Pardon me, not amps, I'm doing resistance, 16 ohms. My apologies. So the answer should be 16 ohms. So if I go down here and I type in 16, and the cell turns purple. And I have this thing set up so that here, if the answer is 7.5, I have it set up to accept a little bit of rounding. So if I round it off and made this 8, it should still work. But then then I need down here to use 8 for my current, and then 120 divided by 8 is 15. So then that should work as well. So it should accept a little bit of rounding. If I round this off too far, um, like 6, that's not, if it was supposed to be 7.5, like dead on, rounding off to 6 is not correct. So that wouldn't work. I hope this helps. Good luck, folks. Let me know if you have any questions. Oh, and up here, it should show you the score that you have when you're done out of 12. I've only done a couple of spots on it. So um, doesn't quite show a great score, but we're on the way. Have a good one, folks.